As I've hinted, this particular question has a little wrinkle. It's similar to example one, person at the top of a 10-meter tall ski hill. This one's got this little wrinkle. Here, I'm gonna doodle a little picture to help us see it. So we got our ski hill, it's 10 meters tall. We got this kid standing up here, standing at rest at the top of the ski hill. And then eventually, here I'll switch colors. Eventually, when they get to the bottom, they're going 10 meters per second. From just common experience with skis or things sliding down hills, why do you think it would be going slower? Best answer to that is friction slows them down. Now we can do some cool math on this. Kind of like what we did last lesson with conservation of energy things. Let's consider how the object started off and how the object ended. In this situation, the object is this kid, started off up high, so that means they've got gravitational energy, but not moving. So no kinetic energy. So their initial energy is all Eg. Instead of setting up an equation, I'm literally, as following letter B here, I'm going to calculate, oops, sorry, jumping all over the place. I'm going to calculate how much energy that actually was. The mass I made up for this person was 60. The G is always 9.8. The height of the hill was 10. 60 times 9.8 times another 10, so we're going to be close to 6,000. The 9.8 number brings it down. You can double check your calculator. I got 5880, and that's a number in joules. How much energy does the person have at the bottom of the hill? Well, at the bottom of the hill, they're at their lowest point, so their Eg has dropped to 0, but they're moving, so they have some Ek. Ek is always 1/2 mv squared. Numbers I made up, 1/2 of the mass of 60 multiplied by 10 squared. Half of 60 is 30. And then multiplying by 10 squared means add 2 zeros, so 3,000 joules. So at the top of the hill, the person started off with 5,880 joules of energy based on how high they were. At the bottom of the hill, based on how fast they were going, they only had 3,000 joules. How many are missing? It is literally almost like an accounting question. Imagine you start off with $5,880 and later you had only $3,000. We can figure out how much energy is missing. Later we're going to call it energy that's lost, although that's not really a great word either. It's literally just a subtraction. 5880 minus 3,000 leaves us with 2880 joules of energy. It's the same basic concept as what we were doing last lesson, conservation of energy. This one has that extra little wrinkle in that some joules may convert or be missing. It's going to be typed in the note next, but basically friction has converted them to heat. When this skier got to the bottom of the hill, their skis would be a little bit warm, maybe a little bit of snow that they skied over had melted a bit, a little bit of heat was generated. Actually, we can go one step further. If we could account for all the heat, 2,880 joules of heat were created by friction as this skier slid down the hill.